My name is Carla Siler-Maddalena. I'm a .NET developer for the past 13 years. Been dabbling in hardware for about 15 now. I am an amateur at this. Even after 15 years, I do this for fun. I have no background in hardware. I'm a computer science major, so starting with hardware blew my mind. That's where this talk came out of. I'm going to set a couple levels here. I'm assuming if you're in this room, you're probably in the same boat I was in 15 years ago. You went to DigiKey or some other site like that, and you went, what is all of this stuff? I'm overwhelmed, I'm done, I don't know how to put this stuff together, and we're going to go back to software. I did that. I've done that recently. The other thing I'm going to assume is you're all developers. I'm not going to go into how to actually install Linux. I'm sure you've all installed Linux. I'm not going to go into how to write a function. Pretty sure we got that one down, right? This is really about how do you get started with stuff you have no concept of. So 15 years ago, come on, buddy. 15 years ago, I was an undergrad major at Western Michigan University. I had no clue about hardware. I'd recently been elected president of the Women Engineering Society. And I was approached by a sponsor that said, hey, I got money. Would you coach a kid's robotics team? Somehow my mind went blank and said, sure, why not? I could do that. No background in hardware at all. So I started working with these 7th graders. We bought a robotics kit, and we started competing in what's called the first robotics competition. I gotta say, the first month was rough. There was no YouTube back then. There was no tutorials. There was no how-tos on blogs. So me and this group of 9 kids, we got frustrated a lot. We yelled a lot. And about a month in, we started making successes. And we started seeing the things we were making actually physically work in the real world. It was the biggest high I've ever had. It was awesome. So about 2 months later, these kids made it all the way to the state championship. We were floored. This was 15 years ago. A couple years later, I met my husband. He started coaching with me. And we decided this was something we wanted to keep doing for the rest of our lives. This was us. So we founded a nonprofit organization called Kalamazoo Robotics. And since then, we've grown from 1 team to 14 teams, 23 coaches, and almost 100 kids every year. And because we've been able to grow as a federally recognized nonprofit, we've also been able to do other projects outside of the season. So we don't just do robots anymore. We do maker projects. We have made Arduino projects. So this whole presentation is born out of how did I start at absolutely no clue about hardware and get to where I could teach 100 kids about hardware. So basically, this whole presentation is laid out in the methodology of how I learned. The first thing I ever did was robots with the kids, different kids. All of the projects I'm going to show you today are made for a kid 10 and under, okay? Don't feel insulted. This is where you have to start. If a kid 10 and under can do it, so can you, okay? The next thing I got into was wearable technology. You want to integrate some cool LEDs into your clothes. You want to make your shoes light up when you walk like the 80s. That's wearable tech. Trust me, I really want to do that. And then I started getting into some homebrew projects. Homebrew is where you're taking pieces of things that maybe aren't part of a kit and putting them together. So you learn how to actually integrate pins and circuit boards and not have a step-by-step direction on how to do it. You will burn things out, buy cheap stuff at first. I also want to give you guys some resources at the end to get started. There's a lot of stuff out there, but there are some really good sites that you can use for these different areas. And I also want to give you some tips to keep you going. You will get frustrated. You will want to throw whatever you're making against the wall at least once a week when you start. So these are things that will help you keep moving along as you get into it, okay? All right, so let's get started. Robotics kits. The most simplistic version of robotics kits are made by Lego. Don't let them fool you with the name Lego. Yeah, there's bricks, and it looks all shiny and colorful. But they actually have a lot of very simplistic concepts that go across the whole hardware spectrum. Sensors are an integral point to not only robotics, maker projects, but also IoT. The difference between IoT in robots, somebody made a set of endpoints so you can get data out of the robot for IoT. That's really what IoT is. You're taking these same components, these same concepts, and putting APIs on them. That's really it. I know because I've written it for work. So there's 4 parts for the most simplistic kit. A controller hub. A controller hub is basically the piece that controls your hardware. You'll write code, compile, download, and then that controller hub will run whatever it is you told it to against all these sensors and hardware. There's motors. So motor's probably a pretty obvious concept. You have a set of power, turn it on left, turn the shaft on right. They have motion sensors, they're called here. There's a couple different names depending on what kind of kit you're talking about. But all it is it has like two little eyes. The little eye on the right shoots out infrared light. The little eye on the left catches back how much infrared light is returned. And it can sense, how are you holding something above it? Is there something blocking it? Motion's a terrible name for it, but it is made for kids K through 3. The last sensor they have in this kit is called a tilt sensor, and it's actually a gyroscope. And what it can do is measure the amount of angle that is at. So if you want to make something that says, if I tip this way, turn on light 1. If I tip this way, turn on light 2. All of the stuff you're doing is very simplistic in nature when it comes to programming it. When you start programming it, this is the interface for K through 3. I have children who do this every year and compete in a competition with it. Okay? The yellow box at the top is just a loop. It'll continue around just like a loop you use in everyday programming. The 2 green boxes are saying set the power of the motor to, and then 75%. Turn the motor on where the shaft is going to the right. And it will only do it based off of the orange box at the bottom. The orange box at the bottom, when you click on it, has a pop-up menu, and it says, what condition am I looking for? And that condition for this is something over the top of it? Are you blocking the light? If it is, turn the motors on. If you're not blocking that light, turn the motor off. That's it. You can keep building onto this over and over, longer, until you get some really complex things. Again, made for K through 3, but a good way, especially if you have kids, to get started. Okay, so if you got bored with that, that was too easy, that was a couple weeks, and you wish you bought something more advanced. This is also made by Lego. And don't let this fool you. When we were in college, we used the first version of this in a couple electrical engineering classes I took. This you can do a lot with. So again, you have the similar concepts. You'll have a controller. You'll download your code to this controller. The controller will then control all of your hardware pieces. You'll have motors. There's different size motors for this kit, so if you need more power, these are actually geared up and down for more power. And then you'll have sensors. A couple of these are very similar to the ones you already saw from the K through 3 kit. The one on the right is ultrasonic. Works like a bat's radar. Sends out a signal, checks how long it takes to come back, and then can make a distance measurement based on that signal. Okay? There's a light sensor. The light sensor actually works kind of like your eyeball does. You look at my pants and they're black. You see black because all of the light spectrum has been absorbed into my pants and no color has been bounced back to your eye. If you see white, it's because all color has now been bounced back to your eye. This works the same way. It sends a light out at the top, and at the bottom it catches how much has been reflected back. So if I see 0%, I know I'm looking at black. If I see 100% of light reflected back, I know I'm seeing white. Touch sensors, you've probably seen something similar. They're called like switches if you used to walk into Radio Shack. All it is a button. It can tell if it's pushed or not pushed. Great for trying to detect things around your area. So you want to know if your robot has run into a wall so it can back up and try again. Check to see if that sensor's pressed. That sensor's pressed, back up, turn, try again. You've seen a Roomba run? Works exactly the same way. Has a big touch sensor in the front of it. Then they have a gyro sensor. It is just a small gyroscope in there, and what it can do is measure the degree of change on the z-axis. So if your robot is like this and it turns 90 degrees, it can tell you that was a 90-degree turn. Okay? So this gets a little more complicated. Once you get more parts, seriously, nobody wants to hear that. This is actually a Lego Rubik's Cube solver. This is all done with just a simple piece of visual programming software and a light sensor and some motors. You can look, there's hundreds of these on the internet. Seriously, go Google Lego Mindstorm projects. Your mind will be blown. Now, when you get more into actually trying to do like very finite things, this is called a line follower. And what it's doing is it's checking the difference between the white and the black line, and it's trying to follow the difference. So every time it sees black, it turns towards white. Every time it sees white, it turns towards black. And it can follow any pattern as long as you have a nice clear line like that. So how do you program that? This is the most simplistic version of a line follower. There's a lot more complicated ones where you can actually take in some math and proportional statistics. This kit we teach with 4th through 8th grade. So we want something very simple. The outside loop basically says, this is a loop, do it for forever. Keep looking. The red brick on the very end is a variable. We set what we think the difference is between white and black. So I said, when you look at my pants, you would see 0 coming back because everything's into it. But if you are looking at white, you're seeing 100% coming back. So what is that difference between the two? It's 50%. So you set your variable at 50%. The yellow brick next to it then reads the value of the light sensor. How much is coming back? So, and then it compares those two. It says, if the light sensor is greater than what we set in the variable, return a true. And this, the green line here, this bluish green line, is your output. That's your return type. If it's less, return a false. And then the orange brick next to the comparer is an if switch. If it is true, I want you to go ahead and turn towards the black. Otherwise, turn towards the white. And what you get is that robot following the difference between the two colors. This is a standard concept used not just in robotics, but in manufacturing also. And you can use this over and over again. It will work every time. It's simple. And it will usually blow a kid's mind if you just use a marker and draw a pattern out and then start doing it. They'll want to try to learn how to do this. Okay, so those are great. They're toys. You want something a little bit more advanced. These are called VEX Robotics Kits. Same concepts again, similar sensors, but what you're actually getting is more of an erector set style, and you're actually going to start wiring your own controller. So all of your hardware comes with so all your sensors comes with bare ends, and you're going to learn how to wire it into the control brick in the dead center of the one on the left. Other perk of this is VEX Robotics Kits come with a wireless controller. The other two are autonomous. You need to pre-program and let environmental sensors direct your robot. These you can actually remote control. These are a little bit more BattleBot style. We use these for our older children up to 12th grade, depending on the kids. They're a lot of fun, and they do stand up to a lot of destruction if you do want to BattleBot with them. Just put that out there. If you really are looking for more of I want to get deeper into understanding how hardware works, how to wire things together, how do the components work together. Boe-Bots are used in classrooms. They're used for middle school education usually. What you see on the screen there looks like two very, very different robots. It is exactly the same kit. What you do get though is the ability, because you have the breadboard on top, is the ability to wire your own components. Sensors are usually $2 to $3 each. They're low cost. They're made for small children to destroy. That's what they are. Because these are educational, there are hundreds and hundreds and hundreds of lesson plans out there for teachers who have no electronics experience. So if you're just starting out, this is kind of a 101, teach yourself, how does this stuff work? And I can't tell you how many variations of the Boe-Bot I've seen. Some that look like spiders, like birds. There's a million. Go look at the tutorials and walk through a few of them. your understanding of hardware integration and sensors will skyrocket quickly. It's a very easy learning curve. All right, I could keep going on and on about robots because I really like robots. But if you just Google robot kits or robot kits for kids, the for kids will get you the most simplistic versions. And you get kits that run $5 from science sites all the way up to a couple $100. They're very, very simple though, and it will help you understand the basic foundations of sensor integration. Okay, the next thing I got into was wearable tech. Kids wanted to learn how to actually make their clothes light up. They were pretty excited about this. So what I have here is called a Gemma. There's a site called Adafruit. It is very big into wearables, and almost all of the kits are like $20 or less. But it'll have step-by-step video tutorials, full documentation, libraries. It's a very well-run site, well-organized. And what you see here is, these are called LED sequins. They're about the size of a grain of rice. And they are actually sewn through magnetic wire to a control board that will control the pattern it lights up. And you can program the pattern stuff. So you get to control how those LEDs work. This was my very first project. It definitely is not high quality. It was the very first version of the Gemma. But it did exactly what it wanted to. I wanted to make things light up, and I did. Here are the pieces that you're going to get. So it's powered by a watch battery, held in by that black container on the left side. That's a watch battery holder. And then you'll plug in that into the control board in the center. That's the Gemma control board. The bottom side looks like a bobbin, is metallic wire. That's actually your circuitry. So when you look at a circuit board, see those gold strips? Those gold strips are now replaced by this flexible silver wire. It will conduct electricity just like a circuit board does. So what you'll do is you'll take that wire, sew it into your control board in the center, and then sew that up into your little Sequin LED lights to pass the electricity in a circuit all along your LEDs. So, not the clearest, so I did this. This is the most simplistic circuit you can do. That little board is your controller. Again, that's where your code goes. You're going to compile it, download it, and then use the libraries that come with it, already pre-built for you, to program how you want these sequins to light up. And if you look on the very side of the lanyard, that's that thread. And all I did was I wove it in and out to make it look nice so it wouldn't hang out. And then each LED sequence, I jumped down, I tied it 3 times around the end, which is a connectivity post. Sewed to the next one, the next one, the next one, coming all the way back down until I got back to the microcontroller here, completing a circuit. The most simplistic circuit you can do, okay? On the back side is a small watch battery pack. And you take 2 of the posts from the control board, sew them to the connectors on the battery pack to power it. That's it. This whole thing that I'm wearing right now took 20 minutes. Now, I did have a friend who had a little girl who wanted her tutu to light up, and he sewed about 100 of those onto one. It was the most adorable thing, but I don't think he ever wanted to sew again after that, ever. Sorry, say again? Oh, hey, I like that plan. I'm a little tired of sewing, so. The code itself is very simplistic. I won't go through this as it's extremely well documented on the site. But basically what you're going to do is each of those posts where you've tied that, or you've sewn that thread around, is going to be considered a pin in this code. And all you're doing is setting where do you want the power to go and how do you want it to turn on and off. All of these functions are already written for you in the library, and there's a full documentation book on how each function works, inputs and outputs. So this whole thing, 15 lines of code, will make it work for the very first time. And if you don't want to write it the first time, go to the GitHub repository for that project, download the code, upload it to the board. You don't have to write anything. My Python, not the best. But being able to see somebody else's Python or C++ or whatever, I'm a .NET developer. This has been years and years ago. Helps me understand what it is I'm trying to do and the best ways to accomplish it. This is another kit I did off of Adafruit called the Neopixel goggles. And basically, it's just 2 LED light rings in a pair of goggles. And you can take these. They're just simple components. They're just 2 LED light rings. You can take all the components on the bottom here. You can wire them up to a pair of fake or lensless frames, I guess would be the word for it, and make them look like a New Year's party. I've seen that done, happy 2018. You're going to get 2 LED rings in the middle. The ribbon cable is going to show you how to wire up between those 2 LED rings to pass data back and forth, so you can actually sync the rings to go in succession together, or if you want them to alternate patterns. On the left is a lithium polymer battery that will power it. It's rechargeable. Your control board is the blue piece at the bottom here. And you're going to wire that up into the battery hole. This is the battery. Sorry, guys, pregnancy brain. Some words don't always come out. The battery controller. And this battery controller will connect to this control board. And what's the word I'm looking for here? Regulate. Thank you. You're my new favorite person. Will actually regulate all your power supply and stuff. You can take all this stuff and hide it in the back on the side of the goggle so you can't really see any of it. But again, you can program it. Libraries are already written for you. You just need to import them and download them. And if you don't want to write the code, go to the GitHub page, download it, upload it to the board, turn it on. It's very, very simple. They've tried to obfuscate a lot of the code, of the hard parts of the code for you. But if you do want to see how they work, you can go into these libraries and really dig in. Starting out, I wouldn't advise that. Okay, so wearables are pretty big now. Adafruit has over 3,000 wearable projects on their site. You can do any of them starting out. None of them are complicated. They have a forum full of really great, nice people who are always willing to help new developers out. And their shop has some really great kits pre-made with step-by-step instructions just to get you started. SparkFun is a similar site. Their blog and shop, different projects, different people, similar concepts. So you have a lot more than just the 3,000 option from Adafruit. MakeZine magazine is a magazine that does not just wearables, but does robotics and other maker projects. It is a wonderful magazine, and their website has all of their stuff free. So you don't even need to buy the magazine if you don't want to try. And they have a lovely section for wearables. All right, so the homebrew stuff. This is the stuff where you're not quite sure how to put it together. Maybe you read a tutorial online and you hacked how that worked, you edited how that worked. One of the big main pieces with a homebrew project is you're going to need some kind of controller. And I'm not sure if you guys have heard of Arduino boards or Raspberry Pis. An Arduino board is called a microcontroller. And the difference between a microcontroller and a computer, which a Raspberry Pi is really a computer, a small computer, is that a Raspberry Pi will run a full Linux OS on it. An Arduino board is a chipset with your RAM and your ROM and everything right on that little tiny board. There is no OS to it. You're gonna write your code. It's usually C++ or C and Arduino libraries, and download it right to that chip. If you have a very simplistic project, an Arduino microcontroller is a great option because you're going to write one C++ script or C script and be done. If you have something you're trying to do that's more than just scripting, a Raspberry Pi is a better option. You have a full service bus here that you can work with, just like you do. The most common Linux installation on a Raspberry Pi is a Debian installation called Raspbian. And it's made specifically to be a full Linux OS, but still work with all of the Raspberry Pi components that are defaulted on it. All right, so the first thing I wanted to highlight is programmable LED matrices. These things are so fun to play with. The idea is that you can actually turn them into a badge. You can display anything you want on these. It's really up to you. With homebrew projects, a good way to kind of cut corners a little bit is use something called hats or shields. Hats or shields are predefined pieces of hardware that clip onto your controller. So in this case, what I used was called a Unicorn Hat HD. It's a 256 LED RGB display. And all of the components, the libraries and everything are pre-assembled and pre-written for me. All I need to do is clip it onto the pins of my Raspberry Pi, like a sandwich, and download the code to the Raspberry Pi. That's it. I don't have to worry about how do I make a circuit board, how do I wire this, what are the right resistors for it. By getting a hat or a shield, it takes care of all of that for you, and it will make your projects very easy. Now this is showing a 2-level stacking of a Pi and a shield, or a hat. Sometimes you can get 3, 4, 5 levels deep depending on what you're doing. And they have shields for everything. They have shields for GPS. You can get ones that do accelerometers. If you can think of a sensor that you've seen today, there's a shield for it. And it's probably pre-built for you, so you don't have to deal with any of the hardware part. Okay. You will have to set, when you get a Raspberry Pi fresh, it is just a piece of hardware. You will need to set up Linux on it. Your choice. Raspbian is the go-to, though, since it is Raspberry Pi specific. GitHub, this Pi Moroni site, is where I purchased the LED shield from. They actually have a great step-by-step tutorial right on the Unicorn Hat HD page of their GitHub site that shows you exactly, step-by-step, how to set up Linux. So if you're like me and you haven't touched Linux since college, which was over a decade ago, this was a big help. So now to the programming. My Python skills, not real good, .NET developer. But what you'll need to do is you'll have to create your own Python script using the Pi Moroni libraries that they've written for you that you've uploaded onto your Pi through the tutorial from the last slide. And then if you're a little unsure of how to write Python, you're an old school developer like I am, you can actually download these right off the GitHub page. There's 15 or 20 examples of different ways to do this, and all of them show exactly how to do it with full documentation. What I really liked about these examples is so my memory is not real good these days, as you've probably figured out over the last half hour or so. They actually have the Linux commands for how to load different things up for this script right in your Pi script, or in your Python script. So you don't have to go, all right, how do I sudo again? What are the commands? I'm a Windows girl. I'm spoiled these days. So in order to get your script on here, whether you've written it or you've stolen it off the GitHub site, you're going to need a Wi-Fi dongle to connect to your Raspberry Pi. That's how you're going to connect in and out. And then you're going to use SSH. And you're going to send that the Python script over to your Pi and then run it on the command line. Now, that doesn't mean you have to have your computer connected to that Pi the whole time. But if you don't want to have your computer connected to that Pi, let's say you want to wear it around a conference, you can use what's called systemd. And this allows you to basically set an auto run on boot. It's a service. You'll set it up, and as soon as the Raspberry Pi finishes booting, it will begin running your Python script. It's very simple to configure. This was a really good tutorial. My husband is amazing at Python. That's kind of his language. And he said that this was probably the best tutorial out there on how to do it. And it was very simple to walk through. I didn't have any problems. There are other ways to set up your Python script as a service. Cron has been used in the past. rc.local has been used in the past. If you're going to use Raspbian as your Linux OS for this, do not use those. Boot sequences have changed. And a lot of the time, the resources that you're looking for are not going to be available when you're booting up on those. All right. The other thing I want to talk about is the garage door indicator. I'm very forgetful. Sometimes I leave the garage door open a lot, and I'd like to have some kind of indicator for myself that says, hey, did I do that? Did I close that today? There's two versions. There's a hardware-only version. Let's say you don't want to deal with the controller, you don't want to code it, you just want it to work. And you're in close proximity to your garage. We can do that through hardware just by creating a simple circuit with an LED light. There's also an IoT version, and this is where that IoT is really just hardware with some APIs. This tutorial is by a guy named Rich Lynch, and he actually uses the APIs for an SMS service, an email service, and a Twitter service to send data from a Raspberry Pi controller so it will alert him in any way he chooses. You will need a Raspberry Pi for this, and you will also need what's called a magnetic sensor. And what a magnetic sensor is two pieces. You have a magnet and you have a sensor. When they separate apart, it can detect that there's no magnet there anymore. When it comes back together, it can detect the magnet has now rejoined. And that will basically be able to tell you, garage door is now open, garage door is now closed. And I'll show you how each one works. So let's start with the hardware-only one. Remember the very beginning we talked about switches, and you could press it, and you'd be able to detect the state, is it pressed or not? This is just a simple switch. And all it is it's L bracketed to the top of the garage by the motor, so that when your garage door comes up, it can hit that switch and say, oh, garage door, the switch is now pushed. That means the garage door is open. If your garage door is closed, that switch isn't pushed. And it can detect the state, just like the kids' robot kits. It's really simple. And you'll need 4 components to make this happen. This is a really, really old tutorial. You can get all of these parts, though, right off DigiKey. It's just a website that has parts. You can probably get most of these off Amazon if you look. So what you're going to need is you're going to need a transformer. It's basically a doorbell transformer. Okay? That's going to give you your power. You're going to need the switch you saw on the last slide. You are going to need an LED light to indicate on and off. So if the LED light is on, indicates garage door is open. And you're going to need a resistor to help with the flow of electricity. That resistor is going to be your key. It's going to make sure it's regulating how much is coming through there. So this is the simplest way. Power is coming out of your doorbell transformer to the left side of the switch there. When the switch isn't pushed, so the garage door is closed, the circuit is open. It can't send electricity over to the LED to light up. When you push the button, it closes the circuit, sends electricity over to LED, LED lights up. That's it. 4 pieces, and the most expensive part of this is probably the wire. You can do this whole project for under 20 bucks. Now, this is given the fact that you hope you have an attached garage and that you want the light pretty close to wherever you're wiring this up. Otherwise, that's going to be a real pain to run. At which point, you can go to the IoT version. So the one on the left is a magnetic sensor. The bottom bar, the bottom silver bar there, is attached to the very, very top of the garage door. That's just a magnet. And then the top piece that actually has the silver coil coming out of it is your sensor. And your sensor is the piece that you're going to mount onto the wall of the garage so it's always stable. And then there'll be 2 wires coming out of your sensor, a ground and a power, basically. And this diagram is actually on his tutorial on how to do this and shows you exactly which pins to use. GPIO stands for general pin in out. Basically, it means wire something here, read it in software. That's what GPIO stands for. And so he'll actually go to the detail of telling you, wire it to this specific one, and then use my code here. So you don't even have to worry about why you would do that. So in his tutorial, you're going to wire the ground to 14 and your power to 16. That's it. You're going to download, again, you're going to have to set up your Raspberry Pi with Raspbian if you have not. On his site, he has the full script already written with the libraries. Download, install. He's got step-by-step instructions. And then the only other step you have to do is set up a configuration file. So which pin did you wire the sensor into? Give it a name so that you know. So let's say you have 2 garage doors. Name could be garage door 1. You duplicate this section below, have garage door 2. State open for the time of at least 120 seconds. Send the alerts to the SMS phone number of 12345, email blah, 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 and Twitter ID blah, blah, blah. That's all you have to do. You don't have to worry about how does that actually work. And in the back, his script will actually connect to the API endpoints for texting, email, and Twitter, and send those alerts for you. So in this example, he's got 2. He's got one at 120 and one at 600. So if he doesn't, he says, at 120, alert me. If I still haven't closed it by 600, go ahead and alert me again. All right, so those are kind of like my favorite things. There are hundreds and hundreds and hundreds of projects out there. I do these with children's K through 12. Go search. I can't even say how much fun it's been just going through all the projects. Like the current one in our house right now is my husband's building an actual 100% working Ghostbusters trap from the original 80s movie. It is the coolest project ever. Found it on the internet. Okay, so resources. If what you saw today, you thought, I can do that. I need some fun stuff. If you like the robot stuff, Lego Engineering Site. It's ran by a group of teachers. They don't do just Lego on there, though. It's really about engineering in general. So how do I get different robots running, different pieces? They're great people. They're really nice. And when I was first starting out, they were my saviors. If you like wearables, Adafruit projects and SparkFun, both great sites, not only for kits, but for people, talking to people on the forums, tutorials. Arduinos and Raspberry Pi forums, you're going to get a lot of loyalists in each one, but they will be honest with you. If you go out to the Raspberry Pi forums and have the most simplistic project out there, they're going to tell you, maybe you should be using an Arduino. But they do have a lot of great knowledge and projects that they post, along with step-by-step how-tos. MakeZine magazine, that's just a fun magazine and website to go to. You don't need anything really complicated. You don't need to have any in-depth knowledge to start with any of their projects. But for a few dollars a month, it might be fun for you and maybe your kids to work on. And then the ever-loving Instructables. There is everything in Instructables. If you want to know how to do anything, that site is the best. It's usually really well documented, lots of pictures, lots of step-by-step. I think that I pulled 1 or 2 of these projects off of Instructables. All right, so this is probably the most important part. How do you not get frustrated and keep going? Start with low-cost items. You're going to burn out boards like you wouldn't believe. We kickstarted the original Raspberry Pi, and I think we burnt it out in 6 months. Keep your parts low cost. Most of what we're talking about is low cost, though. I didn't put anything up here that would cost you thousands of dollars, and most of the replacement parts for the kits you saw, $5 or $10. Not enough to actually break anything. Another tip is work with others. So for me, it was kids. Those kids every year are what keeps me going. But there are other places you can do this. There's maker spaces where people are doing all kinds of projects. They have the equipment you need. So if you want a 3D printer, they have a 3D printer. You want to learn how to solder? They'll teach you how to solder. Those maker spaces, while you won't be working with other people, you'll be able to share the same excitement, though. And that will keep you going, even when you want to throw that project up against the wall because it's not working. The other thing you can do is volunteer for community projects. Just like I don't know if you've ever done this with a group of developers, but a company needs a website or a nonprofit needs some help, you've worked with others. Volunteer for other projects in your area that are outside of development. I'm trying to think of a couple of examples, and I'm like blanking here. We have a community I'm from Kalamazoo, Michigan, And we have a community organization that actually helps associate volunteers with volunteer projects. And that's actually how I found some of the development ones and some of the non-development ones. Look for something like that in your area, and it will help you meet other people. And doing it hands-on with somebody else to teach you, you may have one piece, they may have another. It'll keep you guys moving in one direction. Most important, find something that excites you. If you went through this whole presentation and you're like, oh my God, what a waste of an hour. But I really like that wearable thing. Go do the wearable thing. You may have came in here thinking, I really wanted to learn how to use robotic sensors, and came out thinking, but I really want my shoes to light up now. Go make your shoes light up, guys. That will keep you going. And then you'll get excited for the next project and the next project. Also, ask lots of questions. I know this usually goes without saying, but developers are stubborn. We don't like to not know something, and we don't like to admit that we don't know something. I know that for a fact. The maker community is amazing, and they're very open and very friendly, and you will never feel dumb for having asked. And don't forget, IoT differs from hardware projects only by a set of APIs. Start with the hardware, get it working, and then if you want to make that an IoT, add on the API portion. Most people in here have probably written some kind of web service or endpoint. They're no different for this. All right, I do want to do one special thanks to my husband. Third trimester of pregnancy definitely does some crazy things to your body I was not prepared for when I submitted for this talk. When my hands were too sore to work on the small pieces of the project, or I didn't have the strength in them, he was there to make sure that I could put the parts together, or when I was just so exhausted, like the last couple weeks, that I just didn't want to move off the couch. He was there for me to bounce ideas off of and make sure that I kept everything going. This would not have happened today without him for sure. So thank you, Chris. I'm going to put all of these slides up on my website, techsavvywife.com. Or if you have questions, you can tweet me at techsavvywife. But if you have questions now, I'm happy to take them.